What do plants truly need to live? For most of human history, the answer seemed obvious. Soil, earth, dirt beneath our fingernails, and roots buried in darkness. But what if that was only part of the story? Hydroponics didn't start in a lab. It started with a question. And long before we gave it a name, cultures around the world were already experimenting with an answer. They were growing food and water. Thousands of years ago, stories emerged from ancient Mesopotamia about the hanging gardens of Babylon. Whether they were myth or a real marvel, the descriptions paint a picture of plants cascading down terraces, nourished not by rain, but by a system that lifted water from the Euphrates River. It was a living mountain in the sky. An early attempt to separate plants from soil and feed them through engineered irrigation. Travel west, and we find the Chinampas of the Aztecs on the shallow lakes of what is now Mexico City. They built what were called floating gardens. These weren't truly floating, but were anchored platforms made of mud, sediment, and vegetation. The roots of their crops reached down, constantly interacting with the water below. It wasn't pure hydroponics, but it proved a crucial point. Agriculture didn't have to be confined to dry land. In Asia, rice cultivation developed in flooded paddies. Farmers learned that some crops could flourish when washed. Again, not soil-free, but it pushed human understanding forward. Water wasn't the enemy of roots. Under the right conditions, it was their lifeline. These early systems were born from necessity. Civilizations adapted to deserts, lakes, and floodplains. None of them used the word hydroponics, yet all were inching toward the same discovery. Plants don't eat soil. They absorb nutrients dissolved in water. The scientific unraveling of that truth began in 17th century Europe. A Flemish scientist, Jan Baptist Bangelmon, planted a willow tree in a measured amount of soil. For 5 years, he only added water. At the end, he found the tree had gained significant weight, but the soil's mass had barely changed. He concluded the growth came from water. He wasn't entirely correct, but he had stumbled upon something profound. The soil wasn't being consumed. Fast forward to the 19th century. German botanists, Julius von Sachs and Wilhelm Nob, took the next step. They grew plants in controlled nutrient solutions, identifying the essential minerals needed for life: nitrogen, phosphorus, potassium. They proved that if these elements were dissolved in water, plants could complete their entire life cycle without any soil at all. For the first time, plant growth could be reduced to chemistry. But it was still seen as a scientific curiosity, not a farming revolution. That all changed in the 1930s. At the University of California, Berkeley, William Frederick Jerick began experimenting with large-scale soil-free cultivation. He grew tomato vines over 20 feet tall, using only nutrient solutions. His colleagues were skeptical, so he invited them to see for themselves. Rows of towering plants, heavy with fruit, thriving without a single grain of earth. Jerick coined the term hydroponics, from the Greek words for water and labor, water doing the work. The timing was critical. During World War II, the U.S. military used hydroponics to grow fresh produce for troops on infertile Pacific islands, where soil was rocky or non-existent. Water-based agriculture provided vital nutrition. Hydroponics was no longer just a theory. It was practical. As the 20th century progressed, researchers refined the systems. The nutrient film technique let a thin stream of solution flow over plant roots. Deep water culture suspended roots directly in oxygenated water. Each new method was a blend of biology and engineering, all with a simple goal: deliver nutrients and oxygen efficiently. Meanwhile, urbanization was accelerating. As cities expanded and farmland shrank, innovators started building upward. Vertical farming emerged, stacking hydroponic systems inside warehouses and skyscrapers. Artificial lighting replaced sunlight, and climate control replaced seasons. Crops could now grow year-round, completely independent of the weather outside. The Netherlands, a small country, used these technologies to become a global food exporter. In dense Asian cities and arid Middle Eastern deserts, hydroponics allowed food production where it was once thought impossible. Even space agencies took notice. For long missions beyond Earth, hydroponics offered a way to feed astronauts. In microgravity, where soil would just float away, water-based nutrient delivery was a viable alternative. Experiments on space stations proved what ancient civilizations had unknowingly begun to explore. Plants do not need soil. They need balance. Today, hydroponics exists all around us. It's in the small herb gardens on our kitchen counters, and in massive commercial facilities spanning acres indoors. In these large-scale farms, computers monitor everything in real-time: pH, nutrient levels, humidity, temperature. Water use can be reduced by up to 90% compared to field agriculture, because it is constantly fertilizer pollution is minimized, and soil-borne diseases are eliminated. But hydroponics isn't a magic bullet. It requires electricity, technical knowledge, and a system failure can wipe out crops quickly. The margin for error is small, yet its appeal is powerful. As climate change disrupts weather patterns, hydroponics offers resilience. In drought-prone regions, it's water efficient. In urban centers, it shortens supply chains. What began as floating gardens and experimental willow trees has evolved into a global movement. Different cultures, across different eras, all converged on the same idea. They observed, they adapted, and they innovated. Hydroponics isn't a rejection of nature. It's a refinement of our understanding of it. It recognizes that soil is a delivery system, not a requirement. Once we understood what soil was providing, we could provide it directly. Water becomes the messenger, minerals become the language, and roots become the receivers. From ancient wonders whispered in desert legends to climate-controlled vertical farms glowing in city skylines, hydroponics represents one of agriculture's most fascinating evolutions. It asks a simple but transformative question. If we understand what life needs at its core, how can we reshape the world to sustain it? The answer is still growing. And just like roots suspended in nutrient-rich water, the story of hydroponics is still reaching outward, searching for new ground, even when there's no soil left beneath it. Thanks for watching. If you found this journey through history interesting, don't forget to like and subscribe for more stories about the science that shapes our world.